Hi friends, in this video we are going to solve this particular problem, and this problem given in the JNTUH question paper in the last year BW subject. Now the question is to find the current flowing in each branch of resistor. So question is find the current flowing in each branch. Each branch means what? This here R 3 ohms is connected, and here 4 ohms is connected, here 7 ohms is connected. It means find the value of current flowing through this 3 ohms, as well as find the value of current flowing through 4 ohms, and find the value of current flowing through 7 ohms. For example, what I am doing, the current flowing through 3 ohms, for example, I am giving the name as, for example, I1. Then current flowing through the 4 ohms is, for example, I2, and the current flowing through 7 ohms is, for example, I3. I have given the names for individual currents flowing in individual branches. Now our task is to find the current flowing in 3 ohms, 4 ohms and 7 ohms. So how to find the value of current flowing through 3 ohms and how to find the value of current flowing through 4 ohms and 7 ohms means, now see, for example, if you are going to assuming this is the, for example, this is the node. For example, we are calling as this is the node. Now for this particular node, what is the incoming current? I1 is the incoming current, and from this particular node, I2 and I3 are the outgoing currents. It means whatever the current coming to this particular node, so from this particular current, so I2 and I3 are the divided. It means simply we can say that if you are going to apply Kirchhoff's current law at this particular node point, so we can say that sum of incoming currents means, so in this particular network we are having only incoming current is I1, that is equal to sum of outgoing currents means we are having I2 and I3. Now see here, I2 plus I3 are the outgoing currents and I1 is the incoming current. Now what is happening to calculate the value of current? Now see here, from this particular voltage source, so the I1 is coming. It means the current flowing through the 3 ohms is total current. Okay. The current coming or current flowing through the 3 ohms is the total current supplied by this particular voltage source. But current flowing through 4 ohms and 7 ohms is the currents which are divided from the total current which is coming to the junction node. Okay. So we can say that node. So I1 is the incoming current to this particular junction, and I2 and I3 are the outgoing currents from the junction. It means to find the value of current flowing through 4 ohms, so we can directly apply current division rule. You will get this value, and by applying current division rule, so you will get the value of current which is flowing through 7 ohms. But to calculate the value of current I1, so it is mandatory to calculate the value of total resistance in the network, and after getting the total value of resistance, you are going for the calculation of I1 by using the formula is called as I1 is equal to V divided by total resistance. Okay, so here the V is 20 or 25 volts, and here the value of RT we need to calculate, and after getting these two, so we are going to find the value of total current I1, and after getting the value of I1 with the help of the total current which is available at this particular node point, so we can apply current division rule to find the remaining I2 and I3. Okay, now see here, so first I am going to getting the value of total resistance or equivalent resistance from the given network. Now see here, so here, so 4 ohms and 7 ohms both are connected in parallel. So both are connected in parallel. So both are connected in parallel means how to find the equivalent of these two parallel conversion of 4 ohms and 7 ohms. So simply we can take, so by solving this, finally you are getting the response as, so total resistance, but with the help of this particular 4 ohms and 7 ohms, it means 4 ohms and 7 ohms both are connected in parallel means to get the value of total resistance, so you are going to get the 4 into 7 divided by 4 plus 7. So 4 into 4 into 7 divided by 4 plus 7 means when two resistances are connected in parallel means we can simply multiply those two values divided by addition of these two values. You will get the value of resultant. Now here if you are going to simplify this particular value, so 4 into 7 it will gives what? So 28 and divided by 4 plus 7 means 11. Now if you are going to simplify this one, 28 divided by 11, so it will give the value of total resistance of parallel combination of 4 and 7 as, so RT is equal to, so 2.545 ohms. Now see here, this is the resultant value of what? Parallel combination of 4 ohms and 7 ohms. Now what I am doing, I am going to substituting this resultant value in the actual circuit. Now how I am going to redrawing this particular circuit by replacing the resultant of 4 ohms and 7 ohms parallel combination. Now see here, so here this one is the value of what? 3 ohms and current flowing through this one is I1 and here we are applying 25 volts. Now instead of the parallel combination of 4 and 7 ohms, so we got the resultant as, so here we got the resultant as, so 2.545 ohms. Okay, now after replacing this value, just you can observe that 3 ohms and 2.545 both are connected in series. So here, so 3 ohms and 2.545 ohms both are connected in series. So connected in series. So if both are connected in series means how to find the series connection of both resistances? So we can simply add these two values like 3 plus 2.545. So it will give the value of total resistance is equal to 3 plus 2.545 means you will get the value of 5.545 ohms. Now this is the value of total resistance. After getting the value of total resistance, what we need to find? We need to find the value of total current. Total current is equal to what? Total current is equal to total applied voltage divided by total resistance. Now we can say that total applied voltage is 25 divided by total resistance means 5.545. If you are going to simplify in this one, so you will get 25 divided by 5.545. It will gives the value as 4.508 amperes. Okay. Now this is the value of current, the total current which is flowing in the given network. Okay. Now you can observe that the total current flowing in the network means this particular current is supplied by 25 voltage source. So that is the reason why the current supplied by this 25 voltage source is IT means, so the same current will directly flowing through 3 ohms. So here we can say that IT is equal to I1 because both these currents are same only now. So that's why IT we are getting means that IT is supplied by this 25 voltage source means here I1 is also flowing in this means both are same. Okay. So that is the reason why what I am taking. So here the value of total current supplied by voltage source is equal to the current flowing in the 3 ohms. Okay. Now here that value is 4.508 amperes. Now here the value of current which is flowing through. So here again I am drawing the given circuit like this. Now see. Now this value. Now so this value is 7. This value is 4 and this value is 3 ohms. And this is 25 volts means the current supplied by this voltage source is total current IT means the same current which is flowing in the 3 ohms. It means IT is equal to I1. That's why I am taking the value of IT is equal to I1. Okay. Now coming to the actual concept. It means the total current 4.508 ampere of current is directly flowing through 3 ohms means that particular current directly appear at this particular point because this I1 is the incoming current to this particular node means the current total current available at this particular node is equal to so 4.508 amperes. Now if you know the value of total current available at the junction, you can easily find the value of total current I2 as well as total current I3. Now how to find the current flowing in So 4 ohms. So how to find this particular current flowing through 4 ohms means by using current division rule. Okay. So by using current division rule, so we can easily find the current flowing through this particular 4 ohms. Now what is the current division rule? So current flowing through 4 ohms is equal to, by using the formula, that is, so total current. So total current into opposite resistance, total current into opposite resistance divided by total resistance. Okay, so total current into opposite resistance by total resistance. Now here the total current means the total current available at the junction point, that is 4.508 into opposite resistance means, see here, from this particular junction point we are having the two branches. One is 4 ohm connected branch is connected to this node, and 7 ohm is also connected to node. It means whatever the incoming current to this particular junction point, this particular current is dividing in 4 ohms and 7 ohms. So that is the reason why when we are going to taking the value of opposite resistance and total resistance, so opposite resistance means, for example, if you are finding the value of current I2 in 4 ohms means opposite resistance must be the divided current, the divided remaining current which is flowing in the some other branch. So here the other branch is 7 ohms branch. Okay, now this particular 7 ohms we need to consider as opposite resistance, that is 7 divided by, coming to the total resistance, that is the addition of these two branches, that is what, 4 plus 7. Okay, now here 4.508 into 7 divided by 7 plus 4 means 11. Now if you are going to see this one, so 7 divided by 11, it will gives the value as 0.636. So this one is 4.508 into the value of 7 by 11 means you will get 0.636. Now if you are going to simplify this particular value, that is 0.636 into the value of 4.508, if you are going to multiply these two, you will get the value as, so 2.867 amperes. Okay, so this is the current which is flowing in what? Only the current flowing in 4 ohms. Now if you want to find the value of current which is flowing in the 7 ohm resistance branch, then how to find the current flowing in 7 ohms resistance branch is equal to, again same current division rule, that is total current. So total current, T current means total current into opposite resistance divided by total resistance. Okay, so total current into opposite resistance by total resistance. Now here the total current is same, the total current available at the junction is how much? So 4.508 into opposite resistance is what? Now we are calculating the value of current which is flowing in 7 ohms means now the opposite resistance is only 4 ohms. Okay, so 4 divided by, so 4 plus 7. Now here 4.508 into, so here 4 divided by 11. 4 divided by 11 how much? 4 divided by 11 means you are going to get the value of 0.363. Okay, so 0.363 is the value of 4 divided by 11. Now if you are going to multiply these two values, if you are going to multiply 0.363 into 4.508, if you are going to multiply these two, you will get the value of 1.636 amperes. Okay, so this is the current flowing in 7 ohms. It means we got the current flowing in 3 ohms, that is I1 or IT, both are same because these two currents both are flowing in 3 ohms only. So that is the reason why, so IT or I1 is equal to 4.508 ampere is the current flowing in 3 ohms, and with the help of this particular current available at the junction point, so by using current division rule we got the current flowing in 4 ohms, and by using current division rule we got the current flowing in 7 ohms. Okay, so like this we need to find the value of currents which are flowing in the individual branches of any network. Okay, so thank you so much for watching, and please do subscribe my channel.